Hi, this is Alex Glasgow, and today I'm going to talk more about how you can convert soil test results into a form that relates to actual fertiliser applications. So specifically, kilograms per hectare of nutrient, because when you know that, you can calculate actual fertiliser amounts. With the information provided on a soil test result, you can calculate these nutrient amounts, both surpluses and deficits, in terms of kilograms per hectare. And then based on that, you can calculate actual fertiliser amounts to, say, for example, rectify deficits. Okay, so a little bit of a recap here. Parts per million. We're interested in parts per million because we can convert those into kilograms relatively easily. And the recap here is that you will see soil test results for individual nutrients with quite a range of different nutrients. But in most cases, they are actually just a different way of writing essentially parts per million. So you can see there on that weight basis or volume basis, a lot of those nutrients when they're in those forms are actually already in ppm, parts per million. The exception to this is this milliequivalents per 100 grams result form. We can convert this to parts per million with the formula below. So parts per million equals the milliequivalents per 100 gram number from the soil test result times a constant, and the constant is different for each nutrient. So 391 for potassium, 200 for calcium, and 122 for magnesium. So for example, we can just do a calculation. Potassium equals 0.3 milliequivalents per 100 gram. That's the number from the soil test result. We can do the calculation. Potassium in parts per million is 0.3 times 391, gives an answer of 117 parts per million. So that's how you convert the milliequivalents number into parts per million, which is a more useful number for us to use. Okay, so parts per million into kilograms. Just an example here. If we have a phosphorus result from a soil test, it says 22 milligrams per litre equals 22 parts per million. So therefore, in theory, if we've got 1 million kilograms of soil, there will be 22 kilograms of plant available phosphorus. It will actually be more than that, likely to be a lot more than that, but not all of the phosphorus present will be plant available. That's the thing that the soil test result is looking to do, is just extract the plant available material. Okay, so how much is 1 million kilograms of soil? Just have a look at what that actually means, or how that is determined. To help you picture this, consider an area of 1 hectare and a depth of 75 millimeters. Why 75 millimeters? Well, that's because that's the depth we test to typically in soil. That's the typical soil depth we test to in turf. For soil testing, 75 millimeters. It's where most of the roots are, and it's also realistically the area that we can change with fertilizer applications. So that's why 75 millimeters. Okay, to work out the weight of the soil, it's the volume of the soil times the volume weight of the soil. So the volume of the soil, that's the area times the depth, and so that is 10,000 meters squared, that's 1 hectare, times 0.075 meters, which is 75 millimeters expressed in meters, and that gives us a total volume of 750 meters cubed. So now we can calculate this because we know a volume and we know the volume weight, which is a number on the soil test result. So just an example of that calculation. 750, the volume, times 1.35, which is the result from the soil test. That equals 1,013 tons. And if you want to express that in kilograms, because that's where we're going with this, to kilograms, that equals 1,013,000 kilograms. That's by multiplying the tons by 1,000. So interestingly, that's very close to 1 million. So in this case, if you've got pretty much, when you work out your volume, your soil weight is pretty much bang on 1 million, you can then just say, well, the parts per million results in the soil test result are pretty much equivalent to an actual kilogram amount, but it won't always work out like that. So just to finish this off, just with some calculations and showing you how you can work it out for all these for a soil test result. Let's take an actual soil here. In this case, the volume weight is 0.87. And our volume is the same, 750 times 0.87. That equals 652.5 tonnes. Multiply that by 1,000, 652,500 kilograms. Okay, so that's how much our 1 hectare worth of soil at 2.75 to 75 millimeters deep on this soil with this volume weight. That's how much it weighs. We then have to make an adjustment because we don't have 1 million kilograms of soil. We have a proportion of that. We need to adjust our numbers to give us the right amounts. And so to get our adjustment factor, so to speak, we divide our 652,500 divided by 1 million. It gives us 0.65. And we use this here to do this calculation. And I'll just go through the calculation for this actual soil test result. Phosphorus. This number is already in parts per million, so we don't need to do this stuff down here. It's in parts per million. We've got 16 ppm phosphorus. Multiply it by this adjustment factor of 0.65, and that gives us 10.4 kilograms per hectare of phosphorus. Potassium, we take our milliequivalents per 100 gram number from the soil test and multiply it by our constant. So it's the soil test result is 0.3 times 391 gives us 117.3 ppm, and then multiply that by 0.65, and that gives us 76.5 kgs per hectare of potassium. Calcium, same again, 3.4, that's the result from the soil test, times the 200, that's the constant for calcium, 680 ppm, multiply that by 0.65, and we get 443.7 kilograms per hectare of calcium. And finally magnesium, from the soil test result, 5.6 times 122, the magnesium constant, 683.2 ppm times 0.65, 445.8 kgs per hectare of magnesium. So once we know these numbers, we can start to talk in terms of actual amounts of fertilizer, and we then look at what our target level should be that we're aiming for. And if we're lower than that, we have a deficit, and then we'd be looking to apply fertilizer to correct that deficit. And we need to know these numbers in terms of kgs, because that's the amounts that we apply fertilizers in. So I'll wrap it up there, and next time I will talk further about how you take these kilogram numbers and convert them to actual fertilizer amounts, and calculate how you correct deficits, how you work out how much you need to apply to correct a deficit.